it's ultimately about dollars per kilogram. However much budget the nation's got, we can throw that many kilograms.
I suspect NASA is not as efficient as it might be by a fair amount.
I've been trying to be on a campaign since I retired, trying to suggest NASA that it is worthwhile to attempt to change its design culture, so we design system not for maximum performance and minimum DVT and E cost, but design it with a little more eyesight toward the cost of operations.
Because it's those operations costs that once you're finished with the development, you're stuck with for 10 years, 20 years, 30 years, 40 years, and especially an exploration program, you're going to be facing those costs for a very long time in the future. It would appear that we're in danger of heading down the same path with the current program.
We are on a path right now for a system that requires, on the close order of double the current budget just to operate. If Santa Claus brought us this system tomorrow, fully developed, and the budget didn't change, our next action would have to be to cancel it.
That changes in how we specify and acquire and operate systems, and in what NASA is allowed to do in that respect, have as strong an effect as technology on what we can achieve for a given budget.
The point of purchasing these elements more commercially is to enable there to be innovation and competition among multiple providers.
The choice of the heavy hydrocarbon, which is more aligned with the existing ELV and commercial launch infrastructure, creates the opportunity for the alternative business model that the launch services are largely acquired in a more commercial mode by NASA, even for the heavy lift vehicles.
For all the options that use commercial heavy lift launch vehicles, we're costing them as if NASA doesn't build the system. So this is a commercial buy, and we use NASA infrastructure and the NASA workforce only when it's required to conduct the operation. It brings in considerable efficiencies because you're doing business a new way. You're making a commercial buy out of your heavy lift vehicle. Once you get ISS retired, you've actually got quite a nice little dip there below the budget, and then it kind of ramps up as you're going into significant operations.
This is actually going to the purchasing of incremental costs of more flying hardware. In other words, you can turn this wick up and down in this scenario, which you essentially can't do on all the other scenarios because they're all fixed cost, and this one is dominated by incremental costs. So, and those incremental costs are the ones that we're hoping will come down over time. If you don't like what you're doing, if you don't like what you're getting for your money, you can either spend more money or you can change the price of things over time, which is essentially what research and development is about. Or you can turn some other things off. And the other things are the other 60% of the budget, the various fixed costs. Those are your choices. And so if you don't invest in technology and you don't like today's picture and you don't turn anything off, then when the next commission gets up 10 years from now,
I've been there, done that.
The situation won't look any better.